Okay, hi everybody. Sorry I couldn't be here for you today, but it's really important that we start parametric equations. I don't want to miss out on a day to learn, and I usually have more exciting videos, but I had some technical difficulties to say the least. So what I'm going to do is help you fill out this worksheet that you guys should have, that the sub should have passed out to you, and then I'm going to talk through it though, so I'm going to be doing the examples and talking at the same time. So I know that when I do these videos sometimes I talk kind of fast, so my intention is for you to stop and pause and kind of rewind and re-listen and then think about it. Don't just watch the whole thing straight through because it might be a little bit confusing. So the first thing that you guys need to make sure that you have is your graphing calculator. And hey, look at it. Here's mine right here. Look at that. Woo! Look, it's yellow. I stole it. Okay. And then have this worksheet and then get ready to go. All right. So today we're starting our unit on parametric equations, which somebody pointed out to me yesterday, or not yesterday, but Friday during the test that, oh, Ms. Kreppel, we already did parametric equations in the vector unit, but we just did lines, and so now we're going to do a whole range of different sort of relations with parametric equations. Okay, so what a parametric equation really means, it's kind of not really that big of a deal, but it really means that it just comes in two equations. So there's an x piece, and there is a y piece. So the x part represents the horizontal portions of the graph, and the y piece represents the vertical parts of the graph. Just like always. Now in parametric equations, and you don't see it yet because I haven't done it, but there's also a t. And what we use parametric equations for a lot of times is word problems, and so t usually represents time when you're thinking about that. So the first thing I want you to do is try and graph some. So the first thing you need to do is get out your calculator, make sure that you are in parametric mode. So what you're going to do is take your graphing calculator, hit the mode button, oops, turn it on, hit the mode button, and then here's my choices. Normally we're here where it says function mode is where your calculator usually lives, but arrow over one more and go to parametric mode. And also for the example problems in this unit, make sure that you are in radian mode because it'll make things a lot easier. Don't worry, we're not really doing any trig, so stop freaking out. Okay, now let's go to window, because in order to be successful you have to have a window, otherwise none of these problems will work for you. So hit your window button, and your window should look like this, and there's also a picture of it on your worksheet. So you're going to have now additionally here a new variable. So now we have t values and a t-step. Set your t-step equal to 0.1, x values, y values, and y scale. And then there's like a little picture for you right here in case you want to bring this home if you don't want to rewatch the video. Now, hit the y equals button, and what do you notice on your calculator? Does it look the same? Let's see, I did it. But now for each one, I have an x value and I have a y value for each graph. So everything's broken up into two pieces now. So in parametric equations, everything comes in two parts, an x part and a y part. So let's do this example here first in the middle. So we have this equation that's x is equal to 2t plus 5, and then the second equation is y is equal to negative 3t plus 1. So you probably have no idea what that is. It looks a little bit crazy. You've never seen a parametric equation before. So all we're going to do is practice graphing that. So on the x value, type in what it says there, 2t plus 5. And then on the y part, type in negative 3t plus 1. And then hit the graph button. Oh my gosh, it's a line! Wow, that's so cool. Huh, but where did that line come from? So this line, basically in parametric equations, t is the dependent variable. So kind of like if you think about it as being independent variable. If you think about it, now I can't spell it. The independent variable. So if you think about this in terms of time, so time is the thing that makes things move horizontally, and time is the thing that makes things move vertically. So if I want to actually plot some points on this, I'm going to hit trace, and then I'm going to type in, down here I get all of these points after I hit the trace button. So then what I'm going to do is I'm just going to type in values for t. So I'm going to start with 0. So when t is equal to 0, I get the x coordinate 5, 1. So I'm going to go over 5, up 1. And you could also do that by hand. So if I plugged in 0 up here, the x, I would get 5, and I plugged in 0 for y, I would get 1. So if I plugged in 1 for x, I would get, let's see, when t is equal to 1, x is equal to 7, and y is equal to -2. So I could also plot that point. So 7, -2. Doing that can be a little tedious, so I'll just go back to the calculator, and I'll also plug in like maybe a negative value for t. So I'll plug in when t is equal to -1. So when t is equal to -1, x is 3 and y is 4. So I can plug that point too. 3, 4. And then it looks like my line's moving to the left, so I'll plug in t is equal to -2. And I get the point 1, 7. And then I can just connect that. And there's my line. So what I want you guys to do is take a little bit of time right now, pause the video, and plot each of the functions, or plot each of the parametric equations. And then as you're sketching your graph, I really want to make sure that you plot at least 4 points on your graph. So play around with the t values, try to plug in big t values, see if they're in the window, try to plug in small t values, and then graph that. Okay, so everybody pause and do that right now. Press the pause button. Do it. I hope you press that pause button. I hope you're doing the other problems right now. Okay, so after you finish that, and as you can see, I didn't do it because I couldn't do it in superhuman time, but I will finish these and show you and leave this answer key with the sub for when you guys finish with this video. So I think that if you graphed this one correctly, that you should have seen that this was a parabola that opens up like that, and then this one was a parabola, except this one was a little bit different because this one opens up to the right. So if we go back and think about everything that we've covered so far, pretty much we've only done functions. So this was a function, the parabola opening up. A line is obviously a function, but this parabola that opens sideways is not a function. So one benefit of parametric equations is you can use them to graph non-functions. So that means circles, that means ellipses, that means hyperbolas. It's like all kinds of cool stuff that you can graph if you put your graphing calculator into parametric mode. So play around, try to come up with some other equations, just play around with them and see what you can get on your calculator. So why don't you pause and just play with it for a little while. All right, pause and play. All right, so I hope you enjoyed that freedom. And the next thing we're going to do is really investigate what is the deal with the t? Like, why do we even have that? So, like I said at the beginning, in the future we're going to be using these things for word problems where x is going to represent the horizontal motion, y represents vertical motion, and t is always going to be time. But today we're just going to practice with these equations, and they're just going to be regular equations. And so we're not going to really be doing anything with t other than just playing around with them on regular equations. So the first thing that you guys always have to be prepared to do is what's called eliminate the parameter. So this is just a matter of doing algebra. Okay, so let's start with this first example here in the middle. So we knew that this was an equation of a line because I already graphed it. So I'm familiar with, in the end, what like line equations look like. So it should be something in the form of like y equals mx plus b. So basically all we have to do is do a little substitution here. So I'm going to take the x and I'm going to say, all right, I'm going to solve the x equation for t. So that means I'm going to subtract 5, and then I'm going to divide both sides by 2. So t is really equal to x minus 5 divided by 2. So then I'm going to substitute that back into the y equation. So y is really equal to negative 3 times t, but I'm not going to write t because I just solved for t right here, so it's really going to be x minus 5 over 2. Now if I want to, I can distribute the 3 and combine like terms and do all this stuff, but I don't really want to. So I'll show you guys if you graph that. So now I'll change the mode and go back to function mode, and if I graph that line, negative 3 parentheses x minus 5 divided by 2 plus 1. If I graph that line, it's going to look exactly the same as it did when it was in parametric mode. So those two things are the same. So all we did was we eliminated the parameter, which really is a fancy word for get rid of the t. Okay, so here we started with 2 equations and 3 variables, and here we ended up with 1 equation and 2 variables. So this is our ultimate goal. All right, so we'll come back to what these numbers mean down here on the bottom. So then over here, this one we knew from the back was a parabola. So I know that that's going to end up being some sort of quadratic equation. So again, I'm going to look to see which one of these equations appears to be easier to solve for t. So is it easier to solve something that's quadratic, or is it easier to solve something that's linear? So I'm going to choose this one to solve for t. So that means it's just really as t is equal to x minus 2. So now I'm going to substitute that in. X minus 2 squared minus 1. So as you can see, this is a quadratic equation. It's a parabola that's opening up, which is exactly what we were expecting. So those I'm good with. It's this one that I'm a little bit freaked out by because we got this sideways parabola thing happening. So what I want to do is look at these 2 equations and see which one is easier to solve for. So it looks like this is easier to solve for t. So I'm going to say that t is really equal to y divided by 3. And then I'm going to substitute that back in. Y divided by 3 squared minus 2. So now this is also a quadratic equation, but now instead of it looking like this, y equals some x thing squared, now I have x equals some y thing squared. Which kind of makes sense because that's what made it go sideways, was the y squared, not the x squared. So I'm okay with that too. I got rid of the t, that's your whole goal. So now let's talk about in the middle problem what this meant. So this meant that we can have these 2 equations only as long as t is between the values of negative 2 and 5. So what happens when you get to this equation and it doesn't have any t's in it anymore? So what I have to do is I'm going to limit, this is a line, so it would normally have a domain and range of all real numbers, but I have to limit the domain and range So what I do is I plug in -2 to x, because this is the smallest value here. So my domain, I plug in -2, and when I plug in -2, I get -4 plus 5. So my domain is only going to go from 1, and then plug in your upper t value, which is 5. So 2 times 5 is 10, plus 5 is 15. So that line can only have the domain between 1 and 15, and the range between, I'm going to do the same thing with the y values now. Plug in -2, so that's 6 plus 1 is 7. I think that 7 is going to be bigger though, so I'm going to put it over here. And then I'm going to plug in 5, and that's -15 plus 1. So the range is going to be between -14 and 7. So you only have to do this kind of thing if you start with something, a restriction on your t values. The other two didn't have that. Okay, so now if I look at D, I'm still trying to eliminate the parameter, which means get rid of the t, and I can feel the panic rising in everybody because, oh no, it's sine and cosine. Oh my gosh. Okay. I'm kind of freaking out right now. I'm going to turn my calculator on. I'm going to do mode. I'm going to make sure it's in radian mode, and I'm going to click over to parametric equations. And one more thing that I'm going to do is I'm going to do zoom, and I'm going to pick square, because that's going to make a big difference for us in this. That square means that all of the x tick marks and all of the y tick marks are the same distance apart. So now I'm going to go back, and I'm going to just graph this. I have no idea what this looks like. That's what you're saying to yourself. It's like birthday morning. I have no idea what presents everyone's going to be getting me. I'm so excited. What could it possibly be when I put sines and cosines in there for x and y? Oh my gosh. Wow, it's killing me. Do I push graph? Do I think about it some more? Could it be a hyperbola? Is it a parabola? Is it a line? I mean, the options are endless. Gosh, it's just killing me. Okay, I can't wait anymore. I'm going to push graph. Whoa. Oh my gosh, it's a circle. Oh, good thing Ms. Kreppel spent so long last week reminding us that equations of circles looked like this. X squared plus y squared equals r squared. And I'm sure you're also really happy that no one was freaking out while I was reminding you of that business. So remember, if you have this, x squared plus y squared equals r squared, that means that this circle is centered at the origin, which this one is, and you have to square the radius. So I can shortcut this one and say, I know the equation of this circle is just x squared plus y squared equals 2 squared, because the radius is 2, so I have to square 2, and that's 4. So that's kind of like a shortcut just by looking at the picture and coming up with the equation. But the algebraic way, which I'm sure you're dying to find out, is this. You're really going to like this, okay? I mean, I wish I was here to do it for you in person, because I can just hear. I can hear the excitement. So I'm going to do x over 2 equals cosine t. And I'm going to do the same thing to y. Y over 2 equals sine t. Because remember, my goal is to eliminate the parameter. So I know what a lot of you guys are thinking. Oh yeah, if we want to solve for t, we're going to inverse sine and you're going to inverse cosine. But are there any sines and cosines in this equation up here? No. So here's a little blast from the past. I'm going to square this. I'm going to square this, and then I'm going to add them together. Oh my gosh, this is great. So I get x squared over 4 plus y squared over 4 equals, this is the best, this is so good, cosine squared t plus sine squared t. There's your old friend. Haven't seen that in a while, huh? So basically we know, because we took trig, that cosine squared plus sine squared is 1. So this is x squared over 4 plus y squared over 4 equals 1. And then to get it to look like this equation up here, all you have to do is multiply everything by cuatro. That means 4 in Spanish. And then you get x squared plus y squared equals 4. Wow. Okay. That was really, really fun. Okay, what a great time that problem was. Okay, so now let's see what this one says, E. This isn't really eliminate the parameter anymore because it's asking me to find a parametric equation for a circle with a radius of 6. So if I just think about what I just did, this was a parametric equation of a circle with a radius of 2. So all I had to do was put a 2 in front of the sine and the cosine. So then that means, could it be that easy that all I have to do is this? 6 cosine t y equals 6 sine t. Can't be that easy. I'm going to graph it and look. So I'm just going to change these to 6. Oh no, I'm running out of time. And graph. Good. Look at that. It's the same thing. A circle with the radius of 6 that's centered at the origin. Okay, this video is going to have to be in 2 parts. Now you guys practice F, and I'm going to come back and talk about the last 2 problems.